Hello. All right. So another IncusOS live stream. Last one didn't exactly go to plan as far as me having power and actually being able to run the live stream correctly. So I ended up doing a video instead, which got published on the channel. This time around, things should be better. I actually didn't have power as of 20 minutes ago, but it's all good now. And this time was because the electricians were in the house connecting the second inverter and getting the old battery backup system fully up and running. So I was running a bit of a test just before the live stream, running everything on it. It's correctly splitting between the two inverters. Everything looks good, so should be good from this point on. As I kind of mentioned on social media, this live stream, I'm gonna go back to not Operation Center really briefly. But before that, I'm gonna go through the usual update of what happened over the past week. And there actually was one thing I wanted to do and I forgot before this live stream, so you'll get to all enjoy it happening together. The Operation Center repo, we're actually ready to make that public. Not to be confused with making a stable release or anything. This is not, we're not at that point yet, but we're fine with the repo going public now. So I'm just doing this right now. Make this. GitHub is really wants you to confirm when you want to do that. But anyways, repository is currently public. There we go. So temporarily unavailable, okay, because of publishing, I guess. And here we go. Yeah, so the Operation Center repo is actually public now. We've got a few issues already open, mostly UI related things. There's a bunch of backlog type items we've got internally that we need to actually move to GitHub issues. There's also some kind of niceties now, which is that since we are a public repo, we can finally do draft PRs, which we couldn't do for a little while because of there's some restrictions when you're a private repo. So anyway, that means we can untag this thing. It's now marked as draft, which is good. And we can get rid of that work in progress label since we have draft PRs now. All right, I think that's mostly it for making the repo public. So if you want to go take a look, you can. There's currently no instruction on how to build it, run it on that yourself. That's normal, we're not there yet. We've got instructions now on IncusOS, and we've got some amount of instructions on Migration Manager. Operation Center, it's a bit further from that, but hopefully the next few weeks or month or so, there will be some more instructions. Anyway, as I said, this is not a Operation Center live stream. I just wanted to mention that we've actually made the repo public now. So IncusOS, where are we at? What did we do over the past week? So if we scroll down to about a week ago, that gets us to never kind of confused with the last week tag. I guess we need to actually figure it out. So it was on the 6th. We want to go till the 5th because that was the last live stream. So it was on the 2nd, so we can ignore that. On the 3rd, you can ignore that. 4th, yeah. Flasher tool, I think, was barely. I don't remember if the Flasher tool was merged or if it was about to be merged at the time. But anyways, looks like we're mostly dealing with changes from this point on. So we do have a new Flasher tool with also new instructions on how to build IncusOS. So that's something that can be useful for anyone who wants to test it now. Like we actually have a bit more of a README with some documentation examples, starting step, and effectively that Flasher tool that you can use, which will grab the image from GitHub, let you set up the seed data, and then spit out typically an ISO image that you can then either use in a VM or on a physical machine. So that's a pretty nice improvement as far as usability. There's going to be a lot more we're going to do from that, but it effectively, there's a step-by-step guide for getting started with this stuff. So that was a pretty big change we needed to land, so we're very happy with that. And then there's some of the Operation Center work that's there. So last week I showed the TLS client part. So that's the code that I upstreamed immediately after the live stream. So that's basically as it was in the live stream. And then registration logic that was effectively cleaning up what I showed as a standalone tool last week and turning it into actual code. So we've added in our state struct, we're now keeping track of whether we're registered, so we don't register multiple times. The providers that don't support registration can return a standard error, so we can figure out what's going on. And then the Operation Center provider itself has the registration logic with the same structs that were defined in standalone tool last week, which then figures out a good URL for the local machine, pushes that through the registration endpoint on Operation Center, and then trusts the certificate it gets back from Operation Center into the local trust store. So we've got all of that in place. And then we've got a commit that actually starts making use of that logic. So that's adding registration, and then IncusOS now on startup. So after the applications are started and just before we get into our wait loop, effectively, we handle registration. So if we're not already registered, we attempt to register. We fail if we get an error that's something other than registration and supported. And then if we don't get an error, we go and actually go through registration and mark the system as having been registered. So that's basically where we're at as far as integration with Operation Center. Then after that, we've just done a few tweaks, just licensing and tweaks to the CI. So that's basically where we're at. There's an open PR right now around Secure Boot, so that's been the focus on Friday and the past few days this week, which is setting up a full Secure Boot tree where we can have a offline root key, which is used to sign 2 PKIs, one for Secure Boot, one for the updates. And then both of those PKIs would generate yearly keys that roll over with effectively a bit over a 1-year expiry that then actually sign the images. We're doing that to make sure that we can actually replace the keys, that we do it often enough that we're not really at a super high risk if a key gets compromised for some reason down the line. And also, so we've got a well-tested process so that should a key get compromised for some reason, we have a way to quickly roll out an updated set of keys on the systems. And we're not effectively left having to tell users, hey, you need to manually trust that Secure Boot key, and by the way, you're going to need to enter the TPM recovery key, because that's not a great user experience. We're trying to avoid that. So we're putting all of that in place. Once we've got a good story and good scripts to do all of that, we're going to spend some time moving the image publishing from GitHub to our normal network of image servers. That way we don't depend on the GitHub releases downloads, which have been a bit flaky for us. And as part of that, we're going to move to the new signed index files, the new Secure Boot keys, and all of that. So there's going to be a break again, where effectively we switch from a Secure Boot signing key, which doesn't have a full root of trust, which is just coming off of GitHub, to one where we actually have the full root of trust and everything is in place, and systems deployed from that point on will be able to update onto newer signing keys every year as we roll them out. So that's the main focus we have right now. That's why there's not a ton that happened this week. It's because it's mostly a lot of research and some amount of work to implement the right logic around TPM handling of various measurements for Secure Boot, the Secure Boot validation itself, getting the right files to push to the firmware to update the Secure Boot keys. There's a bunch of complexity, some pretty long specs to read through. So that's what Matthias has been working on our side. All right, did I have anything else to cover? I guess I can just show what we have with the Operation Center integration. So if I connect to the work VPN, okay, that should be good. And I go check that remote. So we've got a work project on one of my clusters, we can see here. It's running a whole bunch of stuff, including 3 IncusOS VMs. So if we'll just list those, can see VM1, 2, and 3, so that's all good. And then we go in Operations Center itself, and we look through the CLI at server list. We can see all 3 VMs have registered with Operations Center. They're showing state ready, so that means that Operations Center is actually able to interact with them. So on the network side, we've effectively got routing and everything working. And now it means that those VMs do mostly update checks through Operations Center. We're effectively at the point now within the work on Operations Center where we're gonna add configuring of network on those, proper storage of the recovery key for encryption, that kind of stuff. And then work onto the clustering step, which is currently you see the clusters being empty. So we want to add the API route and CLI so that you can say, I want those 3 servers to be clustered now, and have Operations Center turn on some features, things like LVM cluster, things like oven and the like, and then assemble the cluster. And once that's done, it will actually be able to list the cluster itself in cluster list, which currently empty. Once that's done, then we will be able to use the other feature of Operations Center, which is inventory, which we can use to then look across all of the registered clusters and systems, what's running on there. So being able to do inventory instance list, and that will list us instances, all instances running and all the projects on all the different clusters. So a lot of that logic already exists in Operations Center. It's just we need to actually get from individual servers to a cluster, and then a lot of the other features then start working. So that's where we're at on that front. Now, for today, as I mentioned on social media, quite a different thing I want to look at. So we've got an open issue in IncusOS, which is here, add USB over IP support. Why would you care about this effectively? It's probably the usual question we get. And the answer is I care because I can't move my own deployments at home to IncusOS until that's supported. And basically what I do at home is I've got a rack with a bunch of servers that runs a Incus cluster. So that's what we can see if we go here. That's one of the servers. And effectively have 3 servers, one Intel Xeon, one AMD EPYC, one ARM server that's a Qualcomm chip. And that's my home cluster. That, with all of the construction work and whatnot that's going on right now, I'm getting ready to actually move my rack and all of the lab environment to a new building on the property. I've got a bunch of dark fiber running between the 2 sites, so between my house and that second building, and the servers will move down there. Now, for the home automation, I've got, I'm running a bunch of different networks here. So I've got Zigbee, Z-Wave, and 433 megahertz. All of those come as like a USB dongle effectively. So I've got that to not have it attached to any one server, so I can still do evacuation and move things around. The way I've done it is that it's attached to a small ARM board that does nothing other than literally exporting all of those over the network. So it's using the USBIP project to run the USBIP daemon, and then it exports all of its USB devices over the network from effectively a Linux system that I don't care about. I don't need to do package updates or anything on that machine because it's just the Linux kernel, one process running, which is USBIP, and it runs on a network with no internet access, completely isolated from everything else, which my servers can then connect to attach those devices. So the way that kind of looks like is I've got 2. So this is the box that has the physical USB devices. So we can see it's got, that's the Z-Wave dongle, that's the Zigbee dongle, got a USB stick, got a, that's the DVB, well, that's a software-defined radio. So that's the 433 megahertz thing I'm using. Then got some network card and the like. So with this, what I then do is I've got this command called export USB, which loads the USB IP kernel module, starts the USB IP daemon with IPv6 support in detached mode, and then does a bit of a reset. So if I rerun the script, it cleans things up. So it first starts by unbinding everything, and then it's got a loop which effectively rebinds the device kind of loop. And it does that every 5 seconds. So it's just running, and any device that drops off that comes back gets re-exported effectively. And with that running, now on the client side, which is that server, I can do attach. And the way that's done is run USB IP attach, then the remote IP, and then the address of the device on the remote side that you want to attach. So if I look at, I don't remember the syntax for this mess, but yeah, something like that. So if we look at 1.2.4.4, which one is that in that mix? 1.2. Never remember how that actually works. It's probably this guy, because it's 1, 2, 4, and it's probably 0.4 is the sub device. Is it? Yeah, I don't remember exactly how you get that. You can get it through sysclass USB or through some other commands. But basically, I'm exporting 3 devices. They're reattached on that remote machine. And that means that if I look at my USB bus on this box, I've got the exact same thing. So I've got the Z-Wave stick, I've got the Zigbee stick, and I've got the, what's the Realtek? Yeah, Realtek SDR. So they just get attached. It looks to the system as if they're on the actual USB bus, even though they're not. And they're just attached over the network. Now, you can use that for a bunch of different things. I mean, this is actually not a bad setup if you have like a lab or something like that, and you've got a bunch of random USB devices, and you want to have them be accessible from a bunch of different systems without having to unplug them. That's particularly useful if you're dealing with like potentially industrial applications or the like, where you can't really move the equipment. You don't really want to keep moving those USB sticks from one machine to another, but you might have multiple systems that need to occasionally interact with them. You can do that. There's a bunch of different ways to do USB over IP. I think there's like literally some physical appliances that do that. This is using the USB IP package that's available on Linux, which does, effectively let you move one of those devices on the source side to be exported and then reattach on the remote side. So there's, like Jared is saying, like maybe, things like YubiKeys could use that too. And yeah, potentially. One thing you probably want to be careful with is that in general, I don't expect USB to take it too kindly for the same device to be attached to multiple systems and be actively used on multiple systems. That's probably a pretty bad idea. So you want to make sure that there's some amount of control on your side about what's attached to where. But in my case, that means I still get to do disaster recovery, where if that machine goes down, I want to attach those somewhere else, I can, which is pretty convenient doing rolling updates and the like. I can temporarily move the instances somewhere else, give them their usual USB devices, and then reboot that machine. I probably would not recommend it for anything that's latency sensitive. So you probably don't want to like have a one of those display adapters that you can run on USB, or a webcam or capture card or microphone or something. You would probably have a pretty bad day because you're adding a bunch of network latency to the mix. But in this case, all 3 devices are effectively character device, so just like basically serial ports, just of different styles. I think 2 of them are TTY USB, one of them is TTY ACM, but it's basically the same concept. They're just serial devices. So to add support for that in IncusOS, what do we need to do? Well, it's going to be another service. So I think I've already done a couple of those on live streams before. But we have inside of IncusOSD, we've got internal services. And in there, we've got a bunch of services already for HKZ, LVM, NVMe, a bunch of those. Let's pick what should be the simplest of the bunch, which I'm not actually sure which one it is at this point. Maybe take LVM as the base for that. So let's copy this guy. And it's going to be a lot of boilerplate, but that's sometimes useful to show because it shows just like how easy it is to extend in IncusOS. So we'll just do a new service called USBIP. What did I miss? CP. Oh, it's because I forgot to actually say that I want to copy LVM. There we go. So that's our new file. And then if we go in here, okay, and you have more mention, and the rest is just the stuff we need to change. Okay, so there's a struct which represents the service. It's got a state, and then from the state, we need to actually define a USB-IP struct in the service state. So that's in Incus API service, and again, we're gonna need to copy LVM here. So service LVM becomes service USB-IP. And the general structure of that will actually be a bit closer to what we have with, say, NVMe, where there's a bunch of targets. So we're gonna need to do something like that in the config with effectively a list of targets. Each of those takes an address and a, I'm not sure how they call the -b option, let's see. But basically a bus address. Yeah, it's bus ID, okay. So it's a remote address, bus ID, and the device itself I've never had to use, so I guess we'll just use these two and see if we need to extend it later. Okay, so editing that service definition, USB-IP here, it's service represent the static version of the USB-IP service. So it's basically just boilerplate naming. And the state is normal. There's effectively no state at this point. And then there's nothing to really enable, unlike the other services, because it's just a command you need to run effectively. And so we just really need to look at whether we have any targets that we need to connect. So as I said, I'm probably gonna just go steal that from the NVMe one. It's gonna be easier. So we'll just pick an NVMe target out of that. Yeah. And then the target list in the config. Okay. So service, that's USB-IP target. Again, more placeholder. No transport, but there's an address, and then bus ID. So this is going to be a string, address, and bus ID. Bus ID. The good thing with it using the bus ID is that it's effectively guaranteed stable. So even if you reboot, so long as you've not physically changed what port the thing is connected to, you're good. It comes back at the same address. Okay, I think the formatting is fine. USB-IP target, USB-IP is fine. We're good here. Okay. Now in here, we need to look at, where is that stuff? Because I just, yeah, never mind, I'm looking at the wrong package. I need to also look at the state package, which ties a bunch of that stuff together. We can see the service list is here. So we need to add USB-IP to that list so we can have our internal state for that as well. Okay, so there's a bunch of the boilerplate for just the config now done and in place. So that means we can the configuration itself should mostly work already at this point. We can even try to see if it builds. Probably not, because enable doesn't exist, system ID doesn't exist, so there's some tweaks we need to do. But basically the way that works, so get is here. So that's fine. Update, we're doing the type change, and there's like, yeah, do we need to enable it or disable it? So that, again, that's not really a thing. Effectively, what we need is to just go through the list of targets and connect to them. There's not, I'm not sure how the detach works actually. I've never had too much luck with detaching, or even with listing things much. Yeah, so that's listing the stuff we could export, not the stuff that's available. We can list things on a remote machine. Does that actually work? To effectively get the addresses out of there. Yeah, not really. I mean, it could be the IPv6. It's kind of confusing, some of those commands, but it doesn't seem like we can just list things. And from what I recall, detach, yeah, detach takes a port, which we don't really know what the port ID is. So it's kind of easy, hard to detach things. So for now, I think the way we'll do it is just implement a single function that goes through the targets called the USBIP attach command for them, and make it so that whenever the list of targets is changed, we'll just go through all of the list and try to attach them all. That's pretty simplistic. We can make it more reliable in the future by adding like parsing of /sys and a bunch of other things to try and figure out what devices are currently there, what needs to be reattached, and get better error out of it. But for a quick first pass, that should be perfectly fine. So that means for the update, we basically defer changing. Stop will be a no op, so it doesn't matter. And the only thing we should really do is, we can update the config basically from the start, because the current config doesn't matter. So we can just update the config from the start. And then we can just do, so start will do the attaching. So we can do attach the devices. So we can do that basically. No need to really do anything else. So that's gonna make things quite a bit simpler. So as we said, stop is just a no op always. So that means we don't need that. We don't need that. And unlike other systems, I mean, the reason for like the fact that we don't support detaching is actually not that problematic, because most of the time when you want to detach one of those USB devices, because it's gonna go away on the sender side, but as soon as the sender stops sharing it, it will get detached automatically anyways. So that's why I'm not too worried about missing the detach logic. It's like 99% of the time you only really need to attach anyways. And then start is where we need to actually do some stuff. So we can wipe that entire function, but basically the logic is load the kernel module, attach all targets. That's basically the logic we need to put in there. Should start if the service should be started on boot. So should start should be always true, basically. Okay. Struct, we just returns our struct, we're fine. Configure was an internal function, I think. That was part of LVM, so we don't need that. And then init is a generic function that we do actually need. Okay, and now we can remove a bunch of imports. Subprocess we're gonna need down the line, but we can just remove it for now and make sure that this thing builds. And it does. Okay. That's not quite all that's needed for an extra service. You also need to add it to the REST API. So need to go API services, And I don't remember how that works. I think it actually iterates over a list of services endpoint. Okay, yeah, the services with valid names. Okay, so it's actually, we don't touch the REST API, but in services, there's another file in here, I think. Yeah, valid names, and we need to add USBIP to the list, and then that will add it to the API. Okay, so at this point, the only thing we really need to do is implementing start. So also there's a kernel module we need to load. I don't remember if we already do that anywhere, loading kernel modules. Where would we have done that? NVMe, I think, might be one of those. What do we do on start? Do we load kernel modules? Yeah, we do. We just call mod probe. Okay, cool. So we should do the same thing here. So the first thing here is that if nothing to be attached, well done. So it's just so that we don't load the kernel module if we don't need to. So state services USBIP config targets. So if that's 0, we just return. Okay, and then we need to actually load that kernel module. Didn't copy that line correctly, so fine. That's this guy we need. Okay. And then the kernel module we needed to load was on that machine in the script, vhci hcd. And then if that fails, we should actually just notice my microphone wasn't on its usual sound dampening microfiber, so my keyboard was probably a bit noisy. Sorry about that. Just fix that now. So we return an error if that fails for some reason. Okay, and then after that we attach all the targets, so it's simply a matter of iterating over the target list. So and state services USBIP config targets, and then attempt to connect. I'm saying attempt because if we restart and it's already attached, that might fail. So we don't want to actually fail the old service if we fail to connect to something. We're just gonna want to log. So we're gonna be logging running subprocess run command context ctx, and then the command is USBIP attach remote, and then target address B and target bus ID. So something along those lines. Also, the error handling, we're not gonna want to return it here. Maybe just an slog warning, unable to attach USBIP device. Address is target address. Bus ID is target bus ID. And then error is this. Okay, we need to import slog, and we need to import the process. Okay, so that's building fine. And in theory, that's basically all we need. Now let's just check static analysis. We didn't mess anything up, and we did. So there's the usual formatting run. Okay, and there's just one small thing to fix. Oops, in the wrong file. Yeah, this guy, 78. We don't actually use this, so there we go. Okay, so that implements the USBIP service and API. Now, one thing that's missing is we don't actually have the command needed to do that. So that's the USBIP command, which comes from the USBIP package. So we need to also add that to the image itself. So that's in base image conf.d. Where's our core packages list here? And we're just gonna add to the mix the USBIP package. Okay, and then we're at this point where we can go and build ourselves a new image. So let's go and do that. All right. I'm still doing that trick where I build what looks like valid images. So actually, is my current trick the correct version? Let me check what the latest tag is, because otherwise what happens is that the first time I boot, it auto-updates to the version on GitHub, which is not very useful. Let me just override that to the current tag there and run make. So now we're building a new IncusOS image from scratch, which is going to include the USBIP package, as well as include the new IncusOSD binary with support for that API. I'm not completely sure of how I'm going to test it yet. Do I have a random USB device I don't care about on my machine that I can expose? Otherwise, what I might just do is just remotely connect to this box. I don't remember what port that stuff is on. So I can just check if I can actually access that beforehand. Okay, USB IPD is on port 3240. Okay, can I reach out to that 3240? Yeah. Okay. I don't know how it's gonna behave with trying to attach the device to multiple machines, but I guess we'll see. Worst case, I'm just gonna stop some of the IoT stuff and then attach it directly and see how that works. I mean, it's not gonna be a great experience because I'm on my desktop machine on Wi-Fi and it's gonna be within a VM on that, but we really just need to have it show up on the USB bus just to be happy. But yeah, that's basically how simple it is now to add a new service to IncusOS. Like if we look at the actual list of files that have been changed for this stuff, it's pretty minimal. Like some of the stuff in here are not directly related. Well, the version thing is not, at least. So yeah, basically adding the API struct with the config that we're expecting, adding the driver, the service in the list of valid services, then writing the service definition itself, which is very simple in this case since we just care about start, and then adding it to the state. And in this case, we also needed an extra package, so we're adding that package and we're good. I just wanted to actually check, because we do trim our kernel build a fair bit. I don't know. I wanted to check that we're not removing all of the USB drivers, because that could be an issue. I don't think that we are, but I'm gonna go check anyways. It's 99 cleanup, I think, that does that. Yeah, so we remove a bunch of stuff, but we don't remove USB, so we should be good. And yes, as Jared says, like most of it was boilerplate, and yeah, and it's pretty boilerplate stuff, but it's also not pointless boilerplate. Like there's not that many code left that's like completely identical that we could try to abstract away to make it even simpler. Like all of the structs, those are definitely needed, and they were pretty simple to put together. And then the service itself, we could simplify it if we had like a shared, like a common service logic that implemented all of the endpoints as just no-op. Then this one would be slightly shorter because we wouldn't even need to have a stop function or have a should start function or have any of those, because they would just be inherited and by default, just do nothing. But that would have saved us maybe what, 8 lines in the service. So Yeah, I kind of like the way it is. It's pretty boilerplate stuff, but also wasn't excessive. Like we didn't need to copy a whole bunch of stuff. There's someone who's new here is like, are you building an OS? Kinda. I mean, it's called IncusOS. It's not. I mean, the OS is Linux, obviously. The kernel itself is Linux. It's based on Debian as the distro, but it's then immutable, completely immutable. So using, in this case, macOSI to generate immutable images. So it's image based for updates, and the goal is to have a extremely locked down environment that just runs Incus. So we can then run that in production environments or in home labs or anywhere where you don't really want to spend too much time babysitting the host system and you just want to focus on running stuff on top of Incus. So that's basically what we're doing. And yeah, I've been doing those live streams for a while now where I go over adding new features to the management service that runs on that OS that actually puts everything together. So in this case, USBIP. Yeah, just Gerald's asking like whether it would be fair to say that like most of the logic comes from macOSI, most of the magic comes from macOSI, and yeah, that's true. Like I mean, even it's actually slightly debatable. Most of the logic these days for like how to do booting, signing, all that stuff comes from systemd. And then macOSI just puts together all of the right systemd bits and configs to turn that into like a immutable system with all of the TPM, secure boot, update logic, kind of all configured correctly. So, but yeah, the systemd project gave us like probably all of the base that we needed to be able to start making those images without having to reinvent the wheel and do a lot of tooling. And then the rest of the magic on our case is in the IncusOS process, because that's what then, once the base OS is up and running, actually goes on and sets up all of the services, network config, registers the system, starts Incus itself, manages the lifecycle, manages updating, does all of that stuff. Which is really great for us because we didn't want to have to invent yet another image building tool. We already wrote distro builder for other kind of images. We don't really want to have to go and do our own tooling to generate our own base images. Just like we didn't want to have to build stuff from source. Like we're very happy to use Debian packages as the base. So it really lets us focus on what matters. So we've got systemd itself and the macOSI projects basically putting the image together. We've got Debian providing most of the user space tools. The kernels are coming actually from the Xabli repo, so I'm the one providing those. Incus packages are also coming from the Xabli repo, so I'm also providing those, and we just kind of put everything together. And the main piece of code that we're actually writing as part of IncusOS is the management daemon, so IncusOSD. That's the main area where we actually need to write code. The rest has been done by others, which is very convenient for us. Okay, so we do have a new image. I just realized I think I didn't make instead of make ISO. So we've got a USB image instead of like a USB disk image instead of running an ISO that installs itself, but make test should be fine in that scenario. Just haven't done it in a little while. I've been really focused on ISO images for the past few weeks or past couple of months, I guess. So anyway, this is now running inside of an Incus VM, and I don't remember with make test if we do the install still. I think we might. Yeah, we do. Okay, so it's installing itself onto the target drive now, which at this point is like nothing unusual. It's just normal IncusOS. We've really improved the install speed. Not something you can really see here in a fast VMs anyway, but we've made it quite a bit faster by really only copying what we need. Okay, so now we're booting onto the target system. Jared saying like a GPT partition. I thought we couldn't use GPTs. Yeah, other GPT. Anyway, not the chat kind. Is referring to the fact that like the Incus project has a no LLM, no AI policy in place. So note no ChatGPT based contributions to our project, but yeah. All right. Okay, so we're getting an error called unknown service. So I'm actually wondering where that's coming from. That's interesting. Bringing up network. Come on. Okay, so we're in a loop here. Let's go see what's going on. The good thing is that it's running as a VM, so we can actually go behind the scenes and see what's up. So we're probably gonna see the exact same error in the log now. Yeah, it just says unknown service. So if we go look in the code, where does that come from? Okay, services load. Would have been nice if that actually gave us, oh yeah, okay. So I forgot a tiny bit of more boilerplate here. We should have USBIP in here, like that. I'm gonna spare you from building the image from scratch. So I'm just gonna do push the binary directly to our existing VM instead, like that, and then stop. Well, I can just bind mount it, and then just gonna need to restart it. So IncusOS and user local bin IncusOS. There we go, and okay. Let's see what we actually get on the console right now. Yay, starting application initializing, we're good. System ready. All right, so this time it actually did start up, which means we can see starting service name USBIP. We might want to do something about that actually, because the issue I've got with what we're seeing now is that every single boot is going to show it, even for users who are not using it. So we should just go and change the USBIP service slightly so that the should start function, which I hard-coded as true, probably shouldn't always be true. What it should do is check if there is any target. So if there's any target listed, then we should start. So let's fix that. Oops, 79. Okay, so that's built. Let's push it over, which we can't because it's actively in use. We can just remove it, push it, there we go. And then remove the bind mounted binary and mount the new one in place. And then restart IncusOS. The best way to do that is actually killing the process. It's here. Otherwise, it tries to do like a clean shutdown of the entire system, which we don't want. Okay, IncusOS is back. If we go look at the console this time, we should see it start up and not show us that the service is starting up because there's no USB IP target at this point. Come on. It's probably not liking the fact that I don't have IP4 connectivity as usual. Because like earlier we saw it complete the startup sequence, but took it a while. There we go. System is ready, we're good. Okay, so with that in place, now we just need to start talking to it. So if we go on the system itself, we can do query /OS 1.0, and we're interacting with the IncusOS API here. So we can see USB IP, targets is showed as null. I don't love that it shows it as null in this case, like an empty list would have been slightly nicer. But I guess that's the same behavior we have for NVMe. No, NVMe we shows it an empty targets list. Okay, let's go at fixing, have a quick go at fixing that. I think it probably has initialization, yeah, in the get function here. So we should do that too. So that works here. Here we go. So initialize the target list if missing, and USBIP, USBIP, and an empty list. I suspect here I need to, no, there's already the API imported. Okay, so we might be good. IncusOS, and then push obviously doesn't work. We need to unmount. Now we can, oh, still not, surprised. Anyway, remove the binary, push, and bind mount. Okay, at which point if we restart it, it's gonna take a little while again. We can watch it restart. Just takes a little while, and after that, the API should give us like an entry that's just an empty list instead. It's gonna be a bit better. And then we can finally try to actually connect it to a USB-IP endpoint. Okay, so this is running. Now if we go back inside it and do the query for USB-IP, there we go, empty target list. Perfect. And normally we could write that down and then change it, but we can also just do a put, and the data for put that matters is config, and then inside config we want targets, and target is a list of structs, and we know the address is from this machine. We can take one of the examples. Let's say we want to pull the SDR. That's the one I care the least about in that list. And then bus ID is the other one. So it's 1-2.1. Okay. That's going to be the only entry in that list. Something odd. That didn't fail. It's listed, but the bus ID is empty. So that's not good. Let's fix that. Okay, now the bus ID is set. And let's see what happened in the journal, because that would have logged something in theory. Okay, so the first time around, unable to attach because, well, there was no bus ID specified, so that makes sense, device not found. Second time, unable to attach, device busy, so it was already exported, so that makes sense. Now, what I can do to test it is go here, stop that loop that keeps reconnecting everything. I'm not going to be able to really detach it from this one because I have no idea how to do that. But I can connect to the device that's sharing those USB devices. And if I can figure out which one I was, it was which one did we want? 1.1-2.1. I can do unbind 1.2.1. Okay. And then within 5 seconds, it's gonna get exported again. Yeah, that's good. At which point we should be able to actually attach it. So if I do a put and I start, actually just doing a normal put should do the trick. So if I do that, it did not fail. Now, yeah, I don't have LS USB, so that's slightly unfortunate. This bus USB, I guess. I'm gonna have to do it the old-fashioned way as far as listing stuff. Okay, which is which on that list? Oh, actually, there's one way I can do it. Incus query 1.0 resources. So that's the Incus resources API, because that has USB devices in a format I can actually understand, I think, somewhere. Do we have more, yes. USB devices, there we go. More is not the most pleasant thing on the planet to use, but okay. Yeah, there we go, it worked. So that's the Realtek semiconductor SDR device. We can see the SDR Smart. So that worked fine. That device is now showing up directly on this particular server. And now if I wanted to move it back to the other, I could unbind it again, wait for it to rebind, at which point it should vanish from this list. It's still visible, but it will disappear. The kernel will notice it's gone soon enough. And if I reattach on my normal server, we should see it come back here. Yeah, it's good. I expect that the SDR IoT function is not happy, so I just need to start it back. And we're good. Now if I do a put, I can just wipe out that list and go back to an empty list of USBIP devices. And now if I query just what we have listed, we're back to empty. Okay, so that actually works fine. We have now the ability to attach USB-IP devices. There's a bunch more that could be done, obviously. Like one thing we would probably want is a background Go routine that checks if something drops off the bus and reattaches them. But that would require actually knowing more information about the device, like exactly what address is going to get on the local system, so we can monitor that. At which point we might also be able to handle detaching. But I would need to poke more at USB IP to really understand how that stuff works, so we can handle it in a smarter way. Right now, it effectively handles it just as dumbly as I am manually with my shell scripts, and that's really all I need for the first stage of that. So I'm gonna need to just slide that into some clean commits, but other than that, we're good to go. So yeah, API, mostly boilerplates for the API itself, adding USB IP to the list of services, adding the loader for it, then the service itself, which is basically as simple as it gets, and then adding it to the internal state struct and making sure the package is actually installed so we have the command we need. And that's it. We've got something that's functional that I can open a PR for in the next hour or so. Send that to a review and we'll have USB IP support. So that's going to be it for this live stream. Probably one of the shorter ones, one where actually everything worked for once. So that's pretty good. Hopefully that gave you a decent overview of where we're at now with IncusOS, like on the Operation Center side and everything, just, the work that was being done over the past few weeks, what we've got coming up as far as the secure boot and update server work, and then the state of the code base and how easy it is to add things with that USB IP work. So yeah, if you want to give it a try, these days there are pretty good instructions directly on the GitHub repo, so you can play with that. Just please don't run this in production yet. You're definitely going to want to wait until we move to the new signing keys before that. Otherwise, it's going to be rough to switch from one to the other. As mentioned before, I have actually run it in production for a week during NorthSec. Worked perfectly fine. I'm looking at starting to run it on some of my machines that are production but less critical, like the stuff I've got at home, and then eventually data center over the next few months. But right now we've got effectively a daily build type update stream without too much testing and validation. Once we've got the new image server, we'll be able to have multiple streams and have our daily builds, but also actual stable builds that we have tested. So that's going to be quite a bit of progress, at which point we're going to start looking at removing some of the alpha labeling and be like, okay, this is still for early adopters, but you have a safe upgrade path from this point on effectively. And so any kind of feature gap or anything we can fix in place and you're not going to find yourself having to reinstall. So that's where we're headed. Hopefully we get there pretty soon. Obviously on the future version side of things, we're actually using this on some production customer deployment, but there we have our own rebuild of IncusOS where we have a bit more control and we can actually do testing, and we've got a Operation Center that can do distribution for us. So we've got those pieces in place. So like we don't really have any extra features, but we have a bit more control on those builds because we've already have our own distribution mechanism there. Whereas for IncusOS itself, we're still at the stage of moving off of GitHub and getting the new signing keys and everything in place. All right. So there's also a question around the ThinkPad. Yeah, so the ThinkPad actually worked fine, I should say. It couldn't do the install of IncusOS like a few months back because of some missing modules, because of some other issue with the console and all that kind of thing. We fixed all of those issues, so it was actually running IncusOS perfectly fine as of yesterday. And then in my chat with Matthias, we were doing some testing around Secure Boot and TPM and stuff on that machine. And I managed to break Secure Boot in a way where I need to actually reinstall IncusOS on it. So I still need to do that, but otherwise, yeah, IncusOS works fine on it. We were actually doing some tweaking to try and improve boot performance, because in the VMs, IncusOS starts in just a few seconds. On my laptop, it takes quite a bit longer because it's trying to start a bunch of things it doesn't need to. So we were doing some systemd analysis to try and cut down what started on boot to get that machine effectively booted up within 10 seconds instead of the almost a minute it takes right now. But yeah, basically we've worked out most of the issues with installing on actual hardware, which also solved it for installing on laptops. All right, well, thanks a lot for watching this one. If you've got any questions on this, feel free to leave them down below in the comment section. You can go on our community forum, as always, to chat with the Incus community over there. Or you can also go and look at GitHub, whether it's Incus or the IncusOS project, to keep an eye on where we're at. And on that, I'll see you in the next one. Bye.